Hello everyone. So let's talk about the rest of the sampling distribution. So previously we talked about the parameters and statistics, and then normal sampling distribution. I talked about central limit theorem, then how we can apply that, and different kinds of sampling distribution, their means and proportions. If you see that sometimes this image doesn't show up, just refresh the page, it should show up, and if it doesn't, let me know. Then we talked about the t distribution as well. It's similar to z, but then again, whenever we do not know the population variance, and then sample size is small, then we go for the t distribution. So I showed you how you can find the critical values. Today, I basically want to talk about sampling distribution of proportions. By the name of it, we can find the proportions. Let's say I want to find the proportion of mountain pine beetle in British Columbia, or maybe proportion of trees that are live in a tree plantation. So that means we can also have the failure or success, that just like in the binomial distribution, what you saw before, we could have two outcomes. Probability of success, we can find that probability of success is P, and then we can find the probability from there, and then we can also find the probability of failure. Previously, you saw that for the binomial distribution, the mean of the population would be sample size multiplied by the probability of success, and then we also saw how we can find the standard deviation. Given those information, what we will try to see, since we are talking about sampling distribution of proportion, that means using the sample, since we are taking it many times, in sampling distribution I showed you how we can do it many times. If we do it many times for statistic P is the proportion. Let's say I take from an area the samples many times, and many times I would find the proportions. And then for the sample proportion, the statistics I found, the values I found, what would be the mean of them? The mean of them would be, that means the average of all those proportions that I took many times would be similar to the true proportion, that means in the population. Similar idea you saw in the sampling distribution for mean. And for the standard deviation for the proportion, we can say the standard error of the proportion would be square root of the proportion of success and failure divided by sample size. That's the same thing we will be using. So to find the probability for each of those cases, all we need to do is to standardize them, just like what we did in the normal distribution. So you will be standardizing them. So you can see that I took the proportion from the sample. Let's say I gave you a sample. You will see in the assignment I gave you some samples, and then you find the proportion from there. You also need the proportion from the population. If you are given the population information, then you can use that population. So the first one is the sample, that means the sample I gave you, and then the second one is the population proportion. And then you have to use the standard deviation you got from the using this data set. After that, you can find what would be, if I get the standardized value, then what would be the proportion. Similarly, just like the Z distribution, when you try to find the probability, we will do the same thing. So you can see that using the sample value, using the population value, and then the standard deviation we got from the data set, we found that the Z value is negative 1.58. For that Z value, you need to go back to the Z table. On the Z table, you need to find out what would be the area under the Z value, negative 1.58. So you will see that the area under the curve would be 0.0571. So that means the proportion we got is that, so you will see we ask you this question. Let me show you. So if I have the distribution, and then in the distribution what we are looking at is the probability of getting less than 3 heads. That means we are trying to find what would be the probability if it is less than 3 heads. So what we try to see is that if it is less than 3 heads, then what would be the probability? So that's our interest. So that means the area under the curve, you can find since it says less than the area, so that's what we are trying to find. So what would be the probability, what would be the mean, and what would be the standard deviation? We got that. What would be the Z value? So that means the Z value we got is somewhere here. So mean is here, but the Z value is negative 1.58. So that means we need to find the probability for this area. If you go to the Z table, you will be easily find the probability under this negative 1.58. So that's what we found. You can check it out. Okay, so maybe you have noticed that we talked about previously less than 3 head, but we use 0.25 so that we know it's not exactly 3. That's why we use 0.25. But if you want to include the 3 heads, it's, let's say it's not less than 3, it's actually including the exactly 3 heads and less, then we can actually talk about it. Let's go a little bit higher for the probability. So that's why you will see that we can use a little bit more probability. Let's not complicate that. So if you want, you can use 0.3, and then you can use less if it is less than 3, or if you want to include that, then you can just include the less than 3 and exactly 3, then it should be fine. So for the sampling distribution of the differences of means, so in this sampling distribution you have to be careful about what's the statistics. Is it the mean, or is it the proportion, or is it the variance, or is it the difference between the means or proportions, or maybe variance? To say that, since we are talking about sampling distribution of the difference between means, that means we have 2 populations, and then in that two population we are getting 2 samples. That means 2 samples you are collecting from the population, and then you are trying to make the difference, whether you want to know whether the population we have, the values we have are the same, population means are the same, or maybe they are not the same, maybe one is more than another one. So depending on what our objective is, then we can find the distribution, then we can find the probability, and we can say that whether they are actually different or not using the statistic. So over here you can see that we mentioned what is the first population mean and variance. In the assignment you will see that sometimes we give you 2 populations, sometimes we give you 1 population. If it is 1 population, then you have to use what I showed you before. If it is 2 populations, then you have to define what is the mean and variance if it is given in the population, and then how about in the second population. When we have the population side by side, we should also have the samples. Since this is the sampling distribution, we need to know the sample value, what's the value for using these samples. If we have the samples, let's say we have samples and then we have some sample size, maybe n1, sample size could be 10, 15, and then the sample mean is, it's 1 bar. You have to give it a notation, since you know that we have two populations, then we have to define what's the mean of the sample from the first population, and then what's the second population, and then from that population, the sample we got, what's the sample mean from that population. That's why we need the difference. And then be careful when you do that, because sometimes you will see that in the question we are saying that the difference between the first minus and then second population, the sample difference maybe, or maybe population difference maybe. So which one is first, which one is next? Otherwise you will see that you are getting the negative values or positive values. That's not what we are asking for. So let's say we have the population mean, and then population mean, you can see that population mean from the first population, second population, and then we are using the combination of the standard of the variance, so that we can get the difference, the standard deviation of the difference between those means. This is called combined or pooled standard deviation. This one is similar to what you saw before. Let me actually draw it in here, it might be easier for you. Okay, so in here you can see we have the Z statistics. That means we are trying to normalize them. When we do that, then you will notice that it's actually following the similar structure we had before. Let me draw them. So the first one is we had before is the mean from the sample. Second one is the mean from the population. And then we had the standard error or standard deviation. You can say that we usually say standard error for the mean. That means we had before sigma divided by root over n. This is similar to what we had. We just added more. So we say that we have to have difference between those two samples, and then difference between two population mean. So that's what we have. And then in the denominator we have the combination of those two populations. So you don't need to remember that. All you can see is that x minus mu and then divided by sigma. So all we have to do is to include the two populations and two samples. Okay. So you can follow through some examples. So you will see that we give you lots of examples, and then whenever you find the Z value, then you can go to the Z table and then find the probability from there. Sometimes you will see that we have, let's say, sample sizes are less, and then we do not know the population variance. So that's the most important one. So whenever you are selecting what's the distribution you have to use, you have to consider the statistics. If it is mean, then you can go for Z or T, but then again for T you have to think about what's the sample size and then whether the population variance is given or not. If the population variance is not given, that means we do not know, we have no idea what's happening in the population, then we have to go for the T distribution. T distribution is similar to what we have seen in the Z distribution. You can see the numerator is same. Only in the denominator we used a pooled standard deviation. So in the pooled standard deviation, you can find the pooled standard deviation using the sample values, the sample variance, and then the sample sizes. So over here, when we are talking about T distribution for the difference between those two means, then you have to consider one more thing. So let me draw that. The two population variances are they're unknown. That's why we are doing T, and sample size is small. But how about whether they are same or not? Let's say two population variances, they are same. Maybe we came to know from the data set, or we came to know from previous studies, or maybe in your assignments it's mentioned. Or if it is not mentioned, then you can assume that. You can say that, let's say they are similar. Or if you find that they're not the same, then you have to treat the standard deviation differently. So you can see that if they are similar in the population, then we can use this equation. The difference is in the standard deviation, that means what we have in the denominator. If they are not same, so let's say we found that they are not same, or we assume that they are not same, then what we can use is this one. So you can see it's a little bit different what we have seen before. So we don't need the pooled part, that means we don't need the pooled part, we just need the sample variance in 2 samples, and then we can directly use that. But in that case, what we have to consider is what would be the degrees of freedom. So you can see that in t-distribution we have to use the degrees of freedom. So in the previous case we can use the simple one, but in the later case we have to use the complicated one. It's not that complicated. All you have to use is the sample sizes and the sample variances. But we can directly use TZ if the sample sizes are larger, both are larger. Then we don't have to use T, we can use Z, and then we can use the sample means and then population mean, and then their standard deviation. Okay. So you will see that in the assignments also, in the examples and exercises, we are using all these statistics, and then depending on the condition, in the objective what is mentioned, then we have to pick the right one. Picking the right one is the first step. Similarly, you can find the sampling distribution of proportion. For the proportion, it's similar. But in this case, we are again just like mean difference, we have to do the difference between those proportions. So the proportion is easier since we are using the z-test. That means we do not need any degrees of freedom. We just need what would be the z value. To find the z value, you will see that what we are using is let me draw in here. So what's the sample proportions difference? This is the sample, and then this is the population. So what's the difference in the population proportion, what's the difference in the sample proportions, and then what's their combined standard deviation. So you can just plug in the sample values, sample proportions, success and then failure, or you can think about what we found before is the P and Q, the let's say live trees or dead trees, something like that. Here is an example. In this example, you can see that we have the proportion. So we have the proportion mentioned, so that means you have to calculate the proportion. So you can see 75 out of 90, and then 75 out of 100, and then into population, then sample sizes are given. Then what is what is the probability? So always draw that. So what is the probability of the difference being less than 0? So that means the less than area, maybe some areas like here, maybe less than or greater than. You have to think about where is it in the middle area, or is it in the upper area, or less than area. Since this is proportion, we always have to use Z distribution, Z table, you can use that. So at first we found the proportions, then so we can say that the proportion follows approximately normal distribution. From the theorem we found that, and then we just plugged in all the values to find the Z value. After we found the Z value, so you can see that Z value is somewhere, so this is the mean, and then somewhere maybe negative 0.859 here. That's the z value. So we need to find what is the probability under this curve. To find the probability, you can go to the z table, just like I showed you before, and you can find that probability is about 0.2% or 0.2. Okay. So that's what it shows in this graph. So always draw the graph. That's always easier to do. So you can see that I don't see the image. So if I refresh this page, then you will see that it will show up. Okay. Now we want to talk about sampling distribution of the difference of paired observation, that means dependent population. So always think about whenever we are giving you two populations, then are they dependent on each other? Let's say students are writing exams, midterm exam and final exam. If I want to see whether there is any difference, since the students who are taking the midterm, they're also taking the final exam, that means they are dependent. There is a relationship between them. So if there is a relationship between them, we have to adjust that relationship, otherwise we will get the bias estimate. So whenever we will give you any population, if I ask you to find the probability of those two populations, the difference between them, then you have to think about are there any dependency going on or not. Sometimes it's mentioned and sometimes it's not. Then you can say that I assume that there is a dependency going on based on what. So you have to explain that. So here is an example we gave you, and then you can see always the statistics is always similar. So you can see over here we have the statistics for T, and then for T at first we have the mean from the sample, just like what we have seen, mean from the sample and then mean from the population, and then their standard, the sigma divided by, sorry my writing is bad, sigma divided by root over n. So that means we are doing the same thing in here, only difference is that we are using the difference, that means the mean difference, the standard deviation for the difference, and then the population, in the population was the mean difference. That's the only thing that you have to consider. Okay. Also the notation changed based, since this is the difference between paired observation. So you can see we have given you an example where we have the 5 students for ST231 and then 211. So both grades is 100, and what is the average difference in these two grades will be greater than some values. So you can see it says the based on 5 pair observations. That means they are different. They are actually not different. They are from the same population, or maybe there is some dependency going on. So the students might be the same. So over here, at first what you need to do, you can see that we have the sample values in those two samples. Since they are paired data, what we need to find is the difference between them. What's the difference between them? For each of those values we have to find, since they are the same students, they are taking them. You can see same 5 students are taking them. So we try to find the difference between them. After that, you can find, using the differences you got, you can find the mean of the differences. Let me clear. Okay. And then that the last part is easy, since we already got this sample mean for the difference, and then in the population what's the mean difference if it's given in the question. So you can see in the population what's the difference, and then we can find the standard deviation of the difference. So after we find that, then we can estimate the t-statistics value. So the t-statistics value, we have to use the standard deviation of the difference. So you can see standard deviation of the difference is similar to what you found out previously for the for a raw data set. For a raw data set, if you have the raw values, then you can find the raw values and you can plug in the raw values. For the differences, the raw values means let me show you. Raw values are here. So these are the raw values. That means these 5 differences, you can use them and then easily find the standard deviation from them. Okay. After that, then you can just find the t value for them. And then since we are talking about the upper area, so you can see the question says that based on the paired data, with the probability average difference in 2 grades will be greater than 22. So that means whether it's greater than 22 or not, whether it's more than 22, what would be the probability for them. So that means we are talking about the upper region, since it's more than 22. And then we found that the t value is 1.67. For the 1.67 t value, what would be the critical value? And then critical value in the table, it will give you the left hand side, that means the less than area. So you can say 1 minus the less than area would give me the upper region. Sampling distribution of variances, it follows chi-square distribution. The chi-square distribution, the structure you can see in here, it's not normal. You can see that it's skewed, and then the standard deviation, the variance we have is almost here. So that means if we take the variance again and again and again, then you will see that the variance would be, the population variance would be somewhere here. Yeah. So for the sampling distribution of variances, whenever we have single variance and whenever we have 2 variances, we have to use 2 different distributions. That's what we mentioned in here. So that means if we have single variance, that means one population only, then it follows chi-square distribution. You can see it's skewed on the right side, so that follows chi-square distribution. Let's talk about the chi-square distribution first. So think about it, always read the objective, read the question. Is it 1 variance or is it 2 variances? One population right now I'm going to talk about. Okay, let me draw that. Okay. So the sampling distribution for one population, one standard deviation we will get, and then one variance we will get, and then all you need to do is to find what is the population variance. Let's draw that. This is the population variance, and then this is the sample variance, and this is the sample size minus 1. So the statistics we have for the chi-square distribution is really simple. We only need to get what is the sample variance, what is the population variance, then you can easily find the chi-square statistics value. But we also need to find what is the degrees of freedom. Degrees of freedom is n-1, and that sample size minus 1. So you can see that since we are talking about the variance, that means the chi-square values cannot be negative. If you find any negative value, that means you did something wrong. Always it will be a positive value. So let me give you an example. So in this example, we have the variance for the population, and then sample size is 20, and then the sample variance is 21. So the chi-square statistics for 19 degrees of freedom, that means sample size minus 1, we found that sample size minus 1, and then sample variance, population variance, we found the value is 11.08. Since we are talking about, let's draw, since we are talking about less than area, so you can see that we are asking whether it's in here, find the probability of sample and then having sample variance less than 21. So that means less than area. So we are basically interested about less than area. Okay, so let's go to the chi-square table. Let me make it larger. Okay, so for the less than values, that means the degrees of freedom was 19. Let me make it larger. For the 19 degrees of freedom, you need to look for 11.08. So 11.08 more close to 10 point, maybe 10.212, or maybe if you use the Excel, or if you use the appropriate one, because sometimes you will see that we cannot find the exact value, then you can take either of them. So you can see that since it's 11.08, I'm using this one because this is more close to this one, or you can use the upper one, but the probability will change. So in this T or Z, you will see that if you cannot find the exact value, you can take the closest one. So I'm taking this closest one, the chi-square 0.5. That means the probability under this curve. So you can see in this table, the chi-square table, it's giving me the less than area. So that means the probability would be 0.05, that approximately. It's not exact because we don't know the exact probability value. So next is the ratio of variances. If it is a ratio of variances, it follows F distribution. So previously you saw Z distribution, T distribution, and then you saw the chi-square distribution. Now we are talking about if we have the ratio of two variances, then we have to use the F distribution. F distribution is, again, it's not like the it's not bell-shaped. You can say it's skewed, and then the ratio of the population variance, that means the ratio is somewhere here in the population, and the lower region and upper region, the critical values are a little bit complicated in F distribution, so you have to be careful about that. So the F distribution is really simple. So you can see that for the F distribution, we have to find out what's the sample size, what's the degrees of freedom for each of those population, and then the samples we got, so what's the degrees of freedom for each of those, and then you have to add. So you can see that the ratio of the sample variance in the sample divided by the population, and then in the sample divided by population. So all we have to think about, because this is you need to consider, so you can see we mentioned at first V1, V2, that means the population 1, population 2. So in the upper area we use the population 1, in the lower, that means the denominator, we use the population 2, second population. So when we actually rearrange, so you can see if we have the ratio of them, then we can take the ratios, rather than showing it this way, we can show in this organization. That means the ratio of the sample variances. In the first population, what is the sample we use, their ratio, and then over here you have to be careful because we use the second population's variance divided by first population's variance. Okay, so that's the most important part you have to consider in the F distribution. So when you are using the F table and try to find the critical value, then many times you will see that you have to consider where in the table the critical values are given. So in this table is a little bit different. So you can see that this is the F table. Let me make it a little bit larger. Okay, so in this table it's giving the upper area. Previously you saw in T and Z it's given the lower area. Also we have the numerator degrees of freedom. This is another thing to consider, and then denominator degrees of freedom, and the probabilities are given in here, and the statistical value you will find is R in the middle. So that means the denominator degrees of freedom, the denominator degrees of freedom is here, numerator degrees of freedom is here, probabilities are on this corner. Okay, so that's why it says that if you want to find F value and then the critical value greater than area, then you can easily find that from the table. But if you are finding it the less than area, then it's not given in the table. So we cannot just use 1 minus because this is not the bell shaped. So that's why you have to consider this equation. So let's say you have the numerator degrees of freedom, denominator degrees of freedom, and then you already know what would be the probability value. If you need the opposite, then you have to use this reciprocal value. So that means what's the value you got? If you get the reciprocal of them, that means then you will find the other area. Let me show you in an example. You can see that we have two sample sizes and then two variances are given, and then find the probability that the ratio of sample variance is will exceed 5.3. So that means we are interested to find the upper region. Let's talk about that first. Then we will also try to find will be less than 0.25. That means the less than area. Okay. In order to do that, at first we need to find the ratio of them. So you can see that the ratio of them is 1.44. That means that's the that's where our ratio is. Then we need to find you can see that the V1, V2, what we find is the V1 is n minus 1, and then V2 is n2 minus 2. That means 9 and 7. V1 equal to 9 and V2 equals to 7. For that, what we try to find is that for that statistic, the F value, we need to find the F statistics value. To do that, what we need to use is that, let me actually clear the picture. To do that, all we need to use is this equation. That means this is the equation we have to use, and then so you can see the ratio of them and then the ratio of the population variance. So that's the same thing we did in here. So you can see that the ratio of the population and the ratio of the samples variances, we use them. So you can see that we use the ratio of the sample variance 5.3 over here, and then the ratio of the population variance. So you have to consider, since we are using the equation, then we have to use the ratio for the second variance, from the second population what we got, and then divided by the first population's variance. That's what we did. So then we found that the value is 3.68. For that value, we need to go to the T table because we are talking about the upper region. That means we can directly find it from the table. Let's go to the table and try to find what would be the value for 3.68. Okay, so let's go to the table. Let's clear these. So in the denominator we have 7, in the numerator we have 9. So we need to use 9 and 7. So you can see these are the values that we have to work on. So you can see for 9 and 7, and then the value we are looking for is 3.68. We found exact value of 3.68. So for 3.68 the probability is 0.05, so we can directly use that. If you see that you cannot find the exact value, so what's the closest value, you can use that. So we just took that value, let's keep it here, and then we used it on our statistical value, so that for more than 5.3 the F statistics is 3.68 and the probability is 0.05. Okay, so this is how we can find that. So the second question was find the probability that will be less than 0.25. So that means we have to look for in the upper region, since we are talking about less than area, because this table is giving you the upper region. So we use the 0.25 and then we found the F statistical value, but the issue is we are getting the we cannot find the less than area. To find the less than area, so you can see that what we did over here to find the less than area, so we use this equation, the equation from the equation from here. So that equation we actually apply that, and we try to find if we actually try to use the less than area, how we can find it by changing the region. So you can see that what we did, we changed the region, but we have to take the reciprocal. So we took the reciprocal 1 over 0.174, and then we found that the reciprocal value is 5.75. So let's go to the table. So you can see that the numerator and denominator, we try to find what would be the closest value. So you can see that the 5.75, so maybe the closest value is in between these two. So that's what it's written. So in between the, let me see that, yeah. Okay, so I just found out that there is an error in this equation. The equation, you took the reciprocal. When you took the reciprocal, then you have to rearrange this degrees of freedom. That means the degrees of freedom at first should be V2 and then V1. That's the same thing we have to do it in here. So whenever we are rearranging them, then let me draw that. Rearranging them, then the F values, what you found it here because of rearranging them, so you have to say that it should be F7 9. It's not 9 7 anymore. So that's what we will try to do. So since we take the reciprocal, so you will see that in the textbook it's written correctly. Since we took the reciprocal, and then we have to go back to our table. Let's go to our table, and then in the table we have to look for the 7 in the numerator and the 9 in the denominator. That means these are the values we should look for. And then the 5.75, that means 5.75 will be close to these two values. So you can say that 5.75 is close to these values. You can pick one of them, or you can say that it's close to these two, or you can say the less than this one or more than this one. So for these two values, so you can see the probabilities are 0 0.01, 0 0.005. That means it's more than 0 0.005, but less than 0 0.01. That's what it's written in here. Okay, so consider that. So it should be 79, not 97. So that's what we showed in the table. That's how we actually draw them. So that's it for the sampling distribution. Thank you all.